Find underwriters, laboratories, or UL certification service for heated mold presses. Here are some steps to consider. Firstly, contact UL directly. Call or visit the UL website to inquire about their UL certification services specifically for heated mold presses. Secondly, search for UL certified laboratories. Visit the UL website and utilize their Find a Certified Lab tool. Filter the search results by equipment category and select machinery or industrial equipment. As a suggestion, choose United States as the location and enter Lyon, New York for the approximate location, if that is needed. Thirdly, identify local service providers. Contact local electrical contractors, equipment distributors, or engineering firms in the Lyon, New York area. Ask if they offer UL certification services or if they can recommend companies that do. Fourthly, request quotes and evaluate services. Obtain quotes from multiple laboratories to compare pricing and the services they offer. Inquire about their experience with UL certifications for heated mold presses, turnaround times, and any additional services that might be required. Fifthly, select a service provider. Choose a laboratory that is reputable, experienced, and capable of meeting your specific needs. Ensure that they are accredited by UL and that they follow the latest safety standards. In addition to these steps, here are some additional tips. Be prepared to provide detailed information about your heated mold presses, including the manufacturers, models, and specifications. Allow ample lead time for the UL certification process, as it can take several weeks or even months to complete. Consider working with an engineering firm or a consultant to assist with the preparation of the technical documentation and to ensure compliance with all UL requirements. The UL Prospector website, ulprospector.com, is a helpful resource for finding UL certified components and materials. By using this tool, one can search for specific products or materials that have already been certified by UL, which can streamline the certification process for the final product. When looking for a UL certification service, it is important to understand the different types of UL marks. The most common UL mark is the UL listed mark, which indicates that a product has been tested and meets UL safety requirements for a specific category of products. There is also the UL recognized component mark, which is used for components that are intended to be used in a larger product. Additionally, there is the UL classified mark, which indicates that a product has been tested for specific properties or characteristics. When evaluating UL certification services, it is important to consider their experience with similar equipment. Ask for references and case studies to get a better understanding of their capabilities. Also, inquire about their knowledge of the specific UL standards that apply to heated mold presses. These standards may include UL 60204.1, which covers the safety of machinery, and UL 508A, which covers the safety of industrial control panels. The cost of UL certification can vary depending on the complexity of the equipment and the level of testing required. Be sure to get a detailed quote from each laboratory that includes all of the costs involved, such as testing fees, inspection fees, and documentation fees. It is also important to understand the turnaround time for UL certification. The certification process can take several weeks or even months, so it is important to factor this into the project timeline. Be sure to ask each laboratory for an estimated turnaround time and to inquire about their process for tracking progress and communicating updates. In addition to UL certification, there may be other certifications or regulatory requirements that apply to heated mold presses depending on their intended use and location. For example, they may need to comply with the requirements of the Occupational Safety and Health Administration or OSHA, or with the electrical codes of the local jurisdiction. Be sure to discuss these requirements with the UL certification service to ensure that they are taken into account during the certification process. Maintaining UL certification requires ongoing compliance with UL requirements. This may include periodic inspections of the equipment and facilities, as well as updates to the technical documentation. Be sure to understand the ongoing requirements for maintaining UL certification and to factor these into the long-term maintenance plan for the equipment. Working with a UL-certified laboratory can provide a number of benefits, including increased safety, improved product quality, and enhanced market access. UL certification demonstrates that the equipment has been tested and meets recognized safety standards, which can help to reduce the risk of accidents and injuries. It can also help to improve the product's reliability and performance, and can make it easier to sell the product in certain markets. When selecting a UL certification service, it is important to choose a laboratory that is accredited by a recognized accreditation body, such as the American National Standards Institute or ANSI. Accreditation demonstrates that the laboratory has met certain standards for quality and competence, and that it is capable of providing reliable and accurate testing services. It is also important to choose a laboratory that has a good reputation and a track record of success. Check online reviews and ask for references to get a better understanding of their capabilities and customer service. In addition to testing and certification, some UL certification services also offer other services such as training, consulting, and product design assistance. These services can be helpful for companies that are new to UL certification or that need assistance with ensuring compliance with UL requirements. When preparing for UL certification, it is important to gather all of the necessary documentation, such as product specifications, schematics, and operating manuals. This documentation will be used by the laboratory to evaluate the equipment and to determine whether it meets UL requirements. It is also important to ensure that the equipment is properly labeled and marked with all of the required information, such as the manufacturer's name, model number, and electrical ratings. The UL certification process typically involves several stages, including application, documentation review, testing, inspection, and certification. During the application stage, the manufacturer submits an application to the laboratory and provides information about the equipment. During the documentation review stage, the laboratory reviews the documentation to ensure that it is complete and accurate. During the testing stage, the laboratory performs a series of tests to evaluate the equipment's safety and performance. During the inspection stage, the laboratory inspects the equipment to ensure that it meets UL requirements. If the equipment passes all of the tests and inspections, the laboratory will issue a UL certificate. The UL certificate is a document that verifies that the equipment has been tested and meets UL requirements. The certificate is typically valid for a specific period of time, and it may need to be renewed periodically. Maintaining UL certification requires ongoing compliance with UL requirements. This may include periodic inspections of the equipment and facilities, as well as updates to the technical documentation. Be sure to understand the ongoing requirements for maintaining UL certification and to factor these into the long-term maintenance plan for the equipment. The National Electrical Code, or NEC, is a widely adopted standard for electrical safety in the United States. While UL certification focuses on product safety, the NEC provides guidelines for the safe installation and operation of electrical equipment. It is essential to understand and comply with the NEC in addition to obtaining UL certification. Article 90. 2 of the NEC covers the scope and purpose of the code, emphasizing the practical safeguarding of persons and property from hazards arising from the use of electricity. Chapter 1 of the NEC provides general requirements, including definitions, wiring methods, and requirements for electrical installations. Chapter 2 of the NEC covers wiring and protection, including overcurrent protection, grounding, and bonding. Chapter 3 of the NEC covers wiring methods and materials, including conductors, cables, and raceways. Chapter 4 of the NEC covers equipment for general use, including appliances, luminaires, and motors. Chapter 5 of the NEC covers special occupancies, including hazardous locations, healthcare facilities, and places of assembly. Chapter 6 of the NEC covers special equipment, including electric signs, electric welders, and industrial machinery. Chapter 7 of the NEC covers special conditions, including emergency systems, standby power systems, and fire alarm systems. Chapter 8 of the NEC covers communications systems, including telephone, radio, and television. Chapter 9 of the NEC contains tables and examples for calculating conductor ampacity, conduit fill, and other electrical parameters. Table 310. 15b16 of the NEC provides ampacity ratings for insulated conductors rated up to 2000 volts based on the conductor's insulation type and ambient temperature. Article 250 of the NEC covers grounding and bonding, which are essential for electrical safety. Grounding provides a path for fault current to return to the source, while bonding ensures that all metal parts of an electrical system are at the same potential. Article 430 of the NEC covers motors, motor circuits, and motor controllers. This article provides requirements for motor overcurrent protection, motor disconnecting means, and motor control circuits. Article 440 of the NEC covers air conditioning and refrigeration equipment. This article provides requirements for the wiring and protection of air conditioning and refrigeration equipment, including disconnects, overcurrent protection, and grounding. Article 670 of the NEC covers industrial machinery. This article provides requirements for the wiring and protection of industrial machinery, including disconnects, overcurrent protection, and control circuits. Understanding the relevant articles of the NEC is crucial for ensuring the safe installation and operation of heated mold presses. In addition to the NEC, other standards and regulations may apply to heated mold presses, depending on their specific application and location. These may include standards from organizations such as the National Fire Protection Association or NFPA, and regulations from state and local authorities. It is important to research and comply with all applicable standards and regulations to ensure the safety and legality of the installation. Proper overcurrent protection is essential for protecting electrical equipment from damage caused by overloads and short circuits. Overcurrent protection devices, such as fuses and circuit breakers, are designed to interrupt the flow of current when it exceeds a safe level. The NEC provides detailed requirements for overcurrent protection, including the selection and sizing of overcurrent protection devices. Ground fault circuit interrupters or GFCIs are devices that protect people from electric shock. GFCIs are designed to detect ground faults, which occur when current flows through an unintended path to ground. When a ground fault is detected, the GFCI quickly interrupts the flow of current, preventing electric shock. The NEC requires GFCIs in certain locations such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters or SIs are devices that protect against fires caused by arc faults. Arc faults are dangerous electrical faults that can generate high temperatures and ignite nearby materials. SIs are designed to detect arc faults and interrupt the flow of current, preventing fires. The NEC requires SIs in certain locations such as bedrooms and living rooms. Surge protection devices, or SPD, are devices that protect electrical equipment from voltage surges. Voltage surges are sudden increases in voltage that can damage or destroy sensitive electronic equipment. SPD are designed to divert surge current away from the equipment, protecting it from damage. The NEC recommends SPD for certain applications, such as sensitive electronic equipment and critical loads. Proper wiring methods are essential for ensuring the safety and reliability of electrical installations. The NEC provides detailed requirements for wiring methods, including the type of conductors, cables, and raceways that are permitted for different applications. It is important to select wiring methods that are appropriate for the environment and the type of equipment being installed. Proper grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to return to the source, while bonding ensures that all metal parts of an electrical system are at the same potential. The NEC provides detailed requirements for grounding and bonding, including the size and type of grounding conductors and bonding jumpers that are required. Electrical enclosures are used to protect electrical equipment from the environment and to prevent accidental contact with energized parts. The NEC provides requirements for electrical enclosures, including their construction, installation, and ventilation. It is important to select enclosures that are appropriate for the environment and the type of equipment being installed. Electrical disconnecting means are used to de-energize electrical equipment for maintenance or repair. The NEC provides requirements for electrical disconnecting means, including their location, accessibility, and rating. It is important to select disconnecting means that are appropriate for the type of equipment being served. Proper labeling and identification are essential for electrical safety. The NEC requires that electrical equipment be labeled with its voltage, current, and other important information. It is also important to identify circuits and equipment with clear and concise labels. Regular electrical inspections are essential for ensuring the safety and reliability of electrical installations. Electrical inspections can identify potential hazards and ensure that the installation is in compliance with the NEC and other applicable standards. It is important to schedule regular electrical inspections by a qualified electrical inspector.